Right. In this video, we're going to talk about solving quadratic equations that have complex solutions. So unfortunately, a quadratic formula, or a quadratic equation, I should say, doesn't always have two real solutions. Sometimes it has one, sometimes it has two, um, sometimes there are none, right? So you would be, you might hear there's two real roots, one real root, or two complex roots. Okay. So we're dealing with complex roots, and that's going to become apparent when under the radical, we're going to end up with a negative number. All right. So recall that for a quadratic equation of this form, we can use the quadratic formula, which is written right here. Okay. So let's go ahead and try that on this first example. First thing I have to do is I have to get it in that form where it has to equal 0. So I need to add 10 to both sides. Which gives me this. Then I can pick off a, b, and c. A is the coefficient on x squared. That's 1. B is the coefficient on x. That's -2. C is the coefficient, or is the constant term at the end. That's +10. Let's plug them into the formula. So we have opposite of b, or negative of a -2, plus or minus the square root, -2 squared minus 4 times a, which is 1, times c, which is 10, all divided by 2 times 1. All right, I'm just going to come over here now. So negative of a -2 makes it 2, plus or minus, under the square root, -2 squared is 4. Then we have 4 times 1 times 10, that's going to be 40, and we are subtracting that. And underneath, we're dividing by 2. Right, simplifying under the radical, we have -36. We've run into this problem before. The negative under the radical needs to be replaced with I. So this is 2 plus or minus. Remember, this is square root of -1 times square root of 36, which is I times square root of 36. Square root of 36 is 6. And then we can break this into two parts. So this is 2 over 2 plus or minus 6i over 2. That's 1 plus or minus 3i. And so our two solutions are 1 plus 3i and 1 minus 3i. So this quadratic equation ends up with two complex roots. And just to let you know what this looks like, I went ahead and plotted it on Desmos. So here's our quadratic equation. You'll note that the parabola does not touch the x-axis. So when you solve the quadratic formula, you're finding what we call the roots, and those are really just the x-intercepts. And clearly this graph does not intercept the x-axis, which is why we get complex solutions. So even if you didn't see the equation, but just saw the graph, you should know that this has complex solutions. All right, here's our last example for complex numbers. This is already in the correct form, so we just need to pull off a, b, and c. A is 2, b is 5, and c is 8. Quadratic formula, right? It's opposite of b plus or minus square root. b squared minus 4ac all over 2a. Plugging in, I have minus 5 plus or minus the square root 5 squared minus 4 times 2 times 8 all over 2 times 2. All right, so let's simplify as best we can. Minus 5 plus or minus the square root 25 minus, now we have 4 times 2, that's 8, times 8, that's 64, all over 4. (25 minus 64). So let's see, we need 5 more to get to 30, another 30 to get to 60, and then another 4. So it looks like 39 and negative. So this one doesn't come out quite as nice. Right, again, I'm going to make this square root of -1 times square root of 39. However, this time, the best I can do is leave that radical alone. Right, 39 is not a perfect square. And if I want to break this into 2 parts, I would do it like that. And then my 2 solutions would be minus 5/4 plus I times root 39 fourths and minus 5/4 minus I root 39 fourths. So unfortunately, that's as nice as you can make that one.